Good afternoon, everyone. How are you all? So, today is a very important chapter. Why I am saying important? Because generally, you will see, definitely, you will see a question from this chapter in the exam. More than one question, two or sometimes three questions in the NEET exam, I will say, and at least one question in the JEE exam. And this chapter is sometimes very easy. Some questions may be calculative. But if I say uh, base of this chapter is not clear to most of the students. They can uh, practice questions, but the basic concept is not clear to most of the students. So we will try to cover up the basics as well in this chapter. So let's start for the first lecture of the alternating current. So we will, first of all, we will see what's the syllabus of this chapter that we need to cover, or I will say what's inside uh, I will say not inside the lecture, inside the chapter, I will say. This is our chapter outline. First of all, we will deal with some basic introduction of the alternating current. Then I will discuss about what is average current, what is RMS current. Then we will discuss some AC circuits. There are overall seven circuits. Then what is power in an AC circuit, and finally transformer. In the meantime, we will also discuss AC generator as well. We will also discuss AC generator. I hope this is clear to everyone. Am I audible properly? Okay. Now moving further for the first slide. That what is alternating current or what is alternating EMF? So if you look, what is alternating current? Any current or any EMF, I am talking about current only. The same definition will be valid for EMF as well. The current which is periodic. I hope you know what is periodic function. The current which is periodic varies continuously with the time and changes its direction after certain time period. Mark my word, after certain time period. That means after some period or fixed period, it changes its direction. Then it is known as alternating current. Can you see the definition? The current or EMF which changes its polarity with the time and is periodic is called alternating current or EMF. Like, for example, you have seen the sine function and the cosine function, the graph of sine and cosine. So let look at that. What is this function? Can you see that the current, if this is current or EMF, you will say, you can take it as EMF and this is some time, then you can see that current is varying continuously with the time. And after fixed time periods, its polarity is changing. This is a function of sine. This is a function of sine. Clear? Similarly, a function of cosine is also there. These two are the alternating formats or alternating most widely used alternating currents, or the format in which we will use some alternating currents is generally in the sine or cosine form. However, there are various forms: sawtooth form, triangular form, square form. Various forms are there, but these are the two widely used. This is a graph of sine. This is a graph of cosine. I hope this is clear to everyone. Now, one more thing. After this simple discussion, what are the two conditions? It must be periodic for current to be alternating. What is the first condition? It must be periodic. What is the second condition? Change its polarity. It must change its polarity. Polarity means direction, or you can also say the direction. It must also change the direction. Then it will be called as alternating current. Clear? Okay, moving further. Now, on the next slide, there are two or three graphs. Then you need to check whether which of this is a alternating current, which of the graph represents alternating current. Okay. Let's suppose this is graph A, this is graph B, and this is graph C. Now tell me which of these graphs I am saying representing AC. Which of these graphs are representing AC? Yes, Rakesh, you can type in your answer. Or if you want to ask something, you can also write in the chat box. Okay. Identify which of the graphs represents AC. This is a simple question. What are the two conditions for a graph to be AC? It must be a periodic function. And you can see all of these are periodic functions. Second condition is it must change its direction or change its polarity. So on behalf of these, I will say graph A represents an AC, graph B also represents AC, and graph C is not AC. Why it is not AC? Can anyone answer? Because the graph C, in graph C, the current is not changing the direction. In graph C, current is not changing the direction. That's why it is not an AC. It's not representing the AC. I hope it is clear. Okay, moving further. So, equation of alternating current. Now, everybody knows these equations. I'm just describing these equations. What are the equations? Like you can represent an AC. I is equals to I naught sine omega t plus phi. It can be plus minus phi. You can use either of these. And or other format, you can say I is equals to I naught cos omega t plus minus phi. I will describe each and every term here as well. First of all, the same equations will be valid for alternating EMF as well. I am writing it for current, but you can write it for the EMF as well, like E is equals to E naught sine omega t plus minus phi. So what are the terms here? What is I? What is I naught? What is omega? What is T? What is phi? So just check it out. I is what? Instantaneous current. I naught is what? Peak current. Peak current means maximum current. Peak current means maximum current. What is omega? Omega is angular frequency and phi is phase constant, or sometimes people may call it as initial phase. Don't worry about this term. I hope you have studied this term phase constant in class 11th SHM and waves chapter. So I hope it is clear to you. But if not, I will describe it in deep detail when we will go further in this chapter, where we will draw phasor diagrams and phase angles. That's going to be a very important part of our discussion. So right now I am just defining the words. What is I? I is instantaneous current. That means at any time t, what is the value of current is called I, is denoted by I. And what is I naught? This term I naught is maximum current, peak value of current. Omega is frequency, which is known as angular frequency. And now few relations that you should remember. Omega is equals to 2 pi f. Angular frequency, and this is your normal frequency. Omega is equals to 2 pi f. One relation that you should remember all the time. It is going to be used very widely in this chapter. Now everybody knows that frequency is reciprocal of time period, or time period is reciprocal of frequency. You can say whatever you want. So from this, we can again form a relation. Omega is equals to 2 pi, and frequency can be written as 1 over time period, that is 2 pi by t. So another golden relation. From here, you know that t is time period. Everybody knows t is time period. Clear? Omega is angular frequency. So relation or t equals to 2 pi by omega, omega t equals to 2 pi, whatever form you want, you can make it. Now, after knowing all these relations, should I move further for the next part of this chapter? This is just the introduction. Same equations can be written for EMF as well. How can you write for EMF? I will say for EMF, you can write the same equations as E is equals to E naught sine omega t plus minus phi, or E is equals to E naught cos omega t plus minus phi. Okay, is it clear? So we have started alternating current. This is the first slide of alternating current, that what is alternating current, or what is the equation, how we can write the alternating current. Before that, we have discussed about periodic functions. That's a part of mathematics, so I don't think it is going to be repeated again, or it should be repeated again. Now, after describing each and every term, we are moving further for the most important part of the chapter. Okay, JNVRR joined. I think you all are some 15 minutes late actually in the class. Okay. So now the most important part of today's discussion is average value and RMS value. These two topics are going to be discussed today. So I hope you will focus. Hemant has joined. Hemant, you are late. I think you joined yesterday as well, and you are late actually. So now listen to me. We are on chapter alternating current. We are discussing this chapter. Till now, we have discussed few of the things, like what is alternating current, how it is represented, or what are the conditions for a graph to be alternating. These few things we have discussed already, not much. So you can consider this is your first topic. What is average value of a function? Now listen to me. Let's suppose you have a function y is equals to ft. This is a function of time. Ab ft, don't get confused. Like, for example, I will say you might have a function y is equals to t square. You might have a function y is equals to root of t, or any function 3t square plus 5t, whatever it may be. That means y is a function of time. And what will be the average value of this function? So average value of this function, first of all, the average value is represented by this symbol, or sometimes it is represented by a sign of bar, mean sign. So what is average value? Average value of any function y is integration divided by time period. So this is the basic fundamental thing by which you can calculate average value of any function. What is the function ft integration ft divided by this term is known as time period. This is nothing but the time period in which you want to calculate the average value. Dt is nothing but the time period. Now, I will give you few examples as well. Now listen to me again. Let's suppose this is some graph. This is y and this is t. And you have drawn a graph of something like that. Then, if you look closely or you have studied in class 11th as well, this ft dt or integration ft dt is what? Area under this graph. Try to remember each and every term I am saying. What is this ft dt represents? This ft dt or integration ft dt is area of yt graph. Clear? So now you can decode it like what is average value? Area of the graph divided by the time period in which they want you to calculate. I think it is clear. Now, if graph is given, then you can follow this formula area divided by time period. If graph is not given, only function is given, then you can use this integration form. So for the calculation of average value, like for example, I will give you an example. I will give you an example here and you need to answer it. For example, you have a function y is equals to t square. The screen is not visible. Is it so? Everyone, I need more responses about that. Is my screen visible to everyone or not? Sujan is saying thumbs up like it's visible, I think. Rashid, Roshan, everyone is saying visible now. JNVRR, you can check whether Roshna, you can say what you want. Okay, JNVR, very good. Very good. Now, question is y is equals to t square is given and they are asking find, okay, very good, average value of y. Can you identify this symbol average value of y from time 0 to 2 seconds, or let's change the time. Let's change the time. It will give you some idea. Let's suppose I'm saying 2 to 4 seconds. Now you need to find the average value of y from 2 to 4 seconds. So what is the average value? How you will find it? Average value of y is going to be integration of t square dt divided by time period. Can you say integration dt means time period? So time period is 2 seconds to 4 seconds. How much time is this? Can you see that this is 2 second time? JNV has joined. Now, what is the limit of this integration? 2 to 4. I hope everybody knows what is the integration of t square. 1 by 2 is already there. This 2 is already there. I have written it here. T square, integration of t square is t cube by 3. Limit is what? 2 to 4. So what it will become ultimately, that is 1 by 8. I hope you know this upper limit minus lower limit concept, that is 4 cube. 64 minus 4, that is 60. that is 15 by 2 something. This is the average value of y. I hope the calculation part is correct, but you will get some idea about how to calculate the average value of a function. If you have any doubt, you can ask me. After that, we will move to, I have not uh, I'm not saying any word about current. This is just a general form, like how you calculate the average value. On the next slide, we will calculate the average value of a function. Clear? Now, the heading you can see is punchlines. So we will discuss some punchlines with you, and those punchlines are going to be very crucial. So I will divide this page and write some punchlines. Listen to me. And you should also write these punchlines. These are very important. So we are talking about average values. You have seen a sine graph, the graph of sine. I hope you have seen. This is the graph of sine, sine theta or whatever you will say. Similarly, you have seen the graph of cosine as well. Now, what I'm saying, what is the first punchline? The average value of sine theta and the average value of cos theta, both are zero. Both are zero. Again, remember my words. I am saying average value of sine theta and cos theta both are zero. For what time? For what time? For one complete cycle. I hope these basic things you know that what is the meaning of cycles. Like this is the starting point, and here one cycle is completed. So this is one complete cycle. So for one complete cycle, average value of sine theta and cos theta is zero. Clear? Again, average value of similarly average value of sine 2 theta and average value of cos 2 theta is also zero. Mark my words. Now another punchline I will say, average value of sine square theta and average value of cos square theta is 1 by 2. And I am writing these values for one complete cycle. I am writing these values for one complete cycle. So I hope you remember all these terms throughout the chapter. Clear? What are the average value of sine theta, sine 2 theta, sine square theta, and everything is on your screen. Give me a thumbs up if you can remember these things. After that, we will move further. Very good. Okay, moving further. Now, average value of AC. You can see from the previous slides what is the AC or how it can be represented. It can be represented like I is equals to I naught sine omega t, or you can represent it in terms of cos omega t as well. Now, if you need to calculate average value of this current, how you will calculate? You will calculate that integration I dt divided by integration of dt. This is again time period. This is, you will know I dt, you need to put the value or it is going to be the area. Now, if I say everybody knows the graph of sine, I will represent it again. If you look at the graph, this is the graph of one cycle. IDT is what area? Can you see that in one complete cycle, this is positive area and this is negative area, and both these areas are equal? That means for one complete cycle, area is going to be zero. And for one complete cycle, area is going to be zero. And that you also know that average value, if you calculate, the average value of sine theta is what? Zero for one complete cycle. So for half cycle, we need to calculate. For what time we need to calculate? We need to calculate for half time period or half cycle, or I will say, I will write a punchline for full cycle, I average is zero. Why zero? I hope it is clear. I hope it is clear why zero. There are two ways I have described. You can say I average is zero for one complete cycle. What are the two ways? For full cycle, average value of sine theta is zero. We have seen on the previous slide. And if you look for the area wise, IDT is the area. This is positive area, this is negative area, and total area for the full cycle is zero. Now for half cycle, if I say for half cycle, you can write it. I average is going to be, put the values. I is equals to I naught sine omega t dt divided by, what is the time period? Dt. Dt is what? Time period. Time period is what? T by 2. That is T by 2. Now, I hope you have completed the chapter in the classroom. Can anyone answer what this value is going to be? If you integrate this term, what is the limit? 0 to T by 2. I'm not going to solve the integration. So if you solve it for half cycle, you will get I average is equals to 2 I naught by pi. You will get 2 I naught by pi. This is the average value of current for one half cycle. Clear? Bacha, you guys are joining, but everyone is joining a bit late. I don't know why, but it will be difficult for you to pick from the mid of the session. So try to join on time. Clear? So what is the average value? 2 I naught by pi. Clear? Moving further. Now, what is root mean square value of current? Sujan is saying something. Look at that. What is root mean square value? So first of all, we will see how to write root mean square value. After that, we will see what is the meaning of root mean square value of AC. So we will describe both the things, like how to write RMS value. First of all, we will learn how to write RMS value. Look at that. Root mean square value of current, I will say, I am writing for current. Similarly, you can write for EMF as well. So first of all, this is your current. Current, then it is going to be squared. Just square it. Take the mean of it. Mean of it means average, and then take a root. This is how you write root mean square value. Are you getting my point? What is the meaning of root mean square value? First of all, square the current, then take its average, then take a root. This is root mean square value of current. How it can be represented in terms of integration? So IRMS can be represented integration I square dt divided by integration of dt total root. This is 0 to t, 0 to t. I hope it is clear. Now what's happening? You can see from the graph of sine. This is the graph of sine theta. The average value was positive in the first half cycle, and in the second half cycle it was negative. But if you square the function, all the values will be positive. All the values will be positive and equal for each half cycle. That means IRMS is same. This is the punchline I'm saying. IRMS is same for half cycle, two half cycles, or I will say one full cycle or long time. For every time, the RMS value is going to be same. Now, look at the values. If you put the value of current here, what ultimate result you will get? IRMS is equals to I naught by root 2. I hope everyone remembers this from your classrooms. What is the RMS value is I naught by root 2. I cannot take the whole class in the integration part. So that's why I'm saying you can remember it easily and you can solve the integration very easily if you put the values of I. What is I? I is equals to I naught sine omega t. Then you will get this result I naught by root 2. Now there are some punchlines that you should remember. One thing that is very important, you need to know how to write this RMS value, how to write its function. Like these two terms, you need to define very properly, and ultimately you need to remember this result. This result is for sinusoidal waves only. Okay, moving further. What are few punchlines? One of the most important punchlines, which also defines RMS current, is this one. What it says, that value of DC current which would produce same amount of heat in a resistor as produced by the actual current in the same resistor in the same time is called RMS current. Is called RMS current. What is the meaning of this? This sentence is very critical and you need to know about that. For example, you have a resistor. You have a resistor R. In this resistor, some current is passing, like suppose I, and this is DC current. In the same resistor, some AC current is also passing. After some time, we have seen when we passed some DC current and we passed some AC current. Now, if I say the in both these circuits, current passes through same time T and produces same heat H, then this value of DC current is known as the equivalent RMS current for this AC. Are you getting my point? This value of DC current is equivalent to the RMS value of this AC current. And this RMS value is also known as effective value. This RMS value is also called as effective value or sometimes virtual value. So you need to remember all these terms about RMS current. Don't worry, this is just a discussion. After that discussion, our main aim is to calculate the questions. to get the answers of the question. So we will do that part after this slide, I hope. There is one more punchline. What is the punchline? Before reading, just look at me. Whenever somebody says like the supply in our houses, it says the meter says 240 volt or 220 volt. This 220 volt is not the maximum value because this is an AC coming in our houses. So this is AC. So which value is they are telling us? They are not telling us the maximum value. They are telling us the RMS value. So what is the meaning of this statement? The AC values are measured by hot wire instruments, and these instruments give RMS value of current and EMF. So whenever somebody says a supply of 220 volt, this is going to be the RMS value. Whenever, if not specified, then every time whenever a supply is given, that means it is going to be your RMS value. Whenever they are talking about ACs. Clear? Okay, so tell me one question. For AC supply, what I'm saying, for AC supply, voltage is given as 220 volt. Then find maximum value. Maximum value of voltage. Can anyone answer very quickly? Can anyone answer what is going to be the maximum value? Anyone? We have seen that VRMS 220 root 2 JNV very good. VRMS is equals to V naught by root 2. So V naught is equals to VRMS into root 2. If you put the value, VRMS is given 220 root 2. Now, the thing is, you need to remember if you put the values of root 2, then you will get 311 volt approximately. And you need to remember this value. The like I will say, good students always remember these values while calculating numerical. It will help you a lot. For which voltage you need to remember, I will say just remember it for example, if VRMS is 200 volt, 220 volt, and 240 volt. Remember these values in maximum terms. Remember V naught for these values. Just keep it in mind. While solving the numerical, you don't need to calculate then. I hope it is clear. Moving further. Now there are some questions for you. Okay. I will give you some 30-40 seconds to calculate each question. This is the first question, and you will get 50 seconds to calculate. Or if you want me to calculate straight away, then you can also say, sir, I am not able to solve. Please solve it. You can say like that. Otherwise, I am giving you some 50 seconds to solve. Anyone getting the answer? Rashid, uh, Rajesh, JNV, RR, Roshna, JNV, what is the name? Lokesh, 2 root 3. 2 root 3 is the average value or RMS value? First of all, we will calculate average value, average current. Okay, JNV, mini coil, LK. First of all, we will calculate average value. Okay, look at that. I average, you have seen that. What is I average? Integration I dt. I is given as 2 root 2, 2 root t dt divided by what? Time period. Time period is from 2 second to 4 second. The students who are not able to solve, please look at the solution. It is very important part of this chapter. 2 to 4 seconds, so time period is 2 second only. Option A, JNVPT is saying option A. So I will check it whether it's correct or not. Okay. The first statement is clear, I will say. Limit is what? 2 to 4 second. This 2 and 2 can be cancelled. What it will become? Integration of root t. Root t integration, if you say, it will be t raised to the power 3 by 2 divided by 3 by 2. Limit is from 2 to 4. And you can take this 2 by 3, it will become 2 by 3. Upper limit minus lower limit, that means 4 raised to the power 3 by 2 minus 2 raised to the power 3 by 2. I hope calculation part is strong for each of you. So it will become 2 by 3. Can you see 3 by 2 means root of 4? Root of 4 means 2, 2 raised to power 3, that is 8, minus 2 cube is 8. Root of 8 is 2 root 2. So this is the average value of current. I hope this is clear. And this option 2 by 3, 8 minus 2 root 2 is only in option A. So from here, you can see that option A is correct actually, because this option is nowhere else except option A. So you can directly mark, but we are here to learn the concept. So that's why I am going to solve for RMS value as well. RMS value. How you can write the RMS value? Just try to learn this here again. IRMS is what? I square dt integration divided by time period. So put the values. If you put I square, it will become 4t integration 4t dt 2 to 4 divided by time period is again 2. That is 1 by 2. Now do the integration. 4 you can take out 2. Integration of t is what? T square by 2. This 2 I have written here. Limit is 2 to 4. That is, this 4 and 4 can be cancelled. This is 8 minus 2. Sorry, 16 minus 4. 16 minus 4 is what? 16 minus 4 is what? 12. And okay, one more thing. This is going to be root. This whole thing is going to be inside the root. Inside the root. So inside the root, it is 12. So it is going to be 2 root 3. This is your final answer, 2 root 3, which is option number A is correct. So we will move towards the next question. And in the next question, I can't see there are options. Okay. Okay, simple question. Simple question. Can you do this question in homework? This is very easy. I don't think we need to give time to this. Okay, if you don't know, then what you can do, the basic equation we have seen is V is equals to V naught sine omega t plus minus phi. From this equation, you can compare V naught, you will get 220 root 2. Omega, you will get 314. And this is sinusoidal function. And for sinusoidal function, we know that what is the average value and what is the RMS value. You know the formulas. So there is no need to solve this question right here. We will move towards next question. Can you compare these two equations? Say yes or no. Can you compare these two equations and solve the question? This is very fundamental question. Everyone should reply in a hurry. Very good. R. Kumar is saying yes, sir. Okay. Moving further for the next question. This is a good question. Now we will see the most important punchline that we have learned. A direct current of value A. That means there is a current, DC current, which has some magnitude A, is superimposed on an alternating current I is equals to B sine omega t flowing through a wire. That means AC and DC both are superimposed. What is the effective value? What is the meaning of effective value? They are asking the RMS value of resulting current in the circuit. You have some 40 seconds to start the question and to solve it. After that, I will discuss. Sorry. Should I start? B divided by root 2. Okay. JNVPT is saying B divided by root 2. Okay. Anyone else with the answer? Now, first of all, there are two currents. One is DC, one is AC. So, what is the total current? If I say what is the total current will be current in the form of DC plus current in the form of AC. And if you combine these two, so total current will become DC is what A, AC is what B sine omega t. Is it clear? Now, how you write RMS value? Now, here is the punchline. How you write RMS value? First of all, take a root. I told you. Then average of I square. This is how you write RMS values. Is it clear? Now put the value of I. If you put the value of I, this I RMS will become root of average of, someone is saying A square plus B square by 2 root JNV McCoy. Very good. I hope this answer is correct. It seems correct. If you square this current, it will become A square plus B square sine square omega t plus 2AB sine omega t average. Now tell me one thing. Everyone should answer the first few steps of this question, like how I calculated total current, then how to write RMS current, and then this step. Are these two, three steps clear to everyone? If it is clear, then our task is going to be very simple now. What I can say, this is the term saying average of this whole term. We can break it like average of a square plus average of this term plus average of this term. A square is a constant value. If I say a value is not changing, it a constant value, then its average will also remain that same constant. So IRMS is equals to, first of all, root is there. I will put a root. Average of a square will not change. It will remain a square plus b square is a constant. It will remain b square. And I told you what is the average value of sine square theta. Average value of sine square theta. Do you remember from the punchlines? Average value of sine square theta was no. Average value of sine theta was 0. Very good. 1 by 2. 1 by 2. Very good. Plus average value of sine omega t is 0. Sine theta is 0. So what is the answer? This is your answer, root of a square plus b square by 2. I hope somebody answered it correctly. I just forgot the name. Uh, can that person, uh, uh, what do you send it again? The person who was correct, I hope. I just don't remember the name. Okay. Is it clear to everyone? That's how you can break the question. On the same note, I am giving you another question to solve right here. We have some time, so we can utilize that time to solve one more question of the same type. Okay, here is your another question. Current is given I1 sin omega t plus I2 cos omega t. Find the RMS current. Find the RMS current. You have some 30-40 seconds. Very quick. Be very quick to answer. And everyone should participate now. Quick, quick, quick. These questions are very popular among JE exams. In many shifts, like in previous year, not previous year, I will say this year in 2023, a lot of questions were asked about RMS current and average current or average EMF, including graphs as well. So the kind of that question is on the next slide. I hope this kind of question is also there. First thing that everyone should learn at least is how to write IRMS. Put a square, put average symbol, I square, and that's it. Now you can put the values. IRMS is equals to root of. If I square it, it will become a very difficult term or not. That will be I1 square sine square omega t. Can you square with me? Plus, okay, someone has answered root of I1 square plus I2 square. Okay, let's check it. I1 square sine square omega t plus I2 square cos square omega t. Is it clear to everyone? Plus 2 I1 I2 sine omega t cos omega t. Is it done? Average of these values. Now, if I talk about average of these values, you can break it like average of first term, average of second term, plus average of third term. And it is very clear. We know the punchlines. Average of sine square omega t is what? Everybody knows. This is 1 by 2. So this is I1 square by 2. Similarly, plus I2 square by 2 plus. If you see this term, I1, I2 sine omega t cos omega t. Can you see this? If you multiply these two terms, it will be sine 2 omega t or sine 2 theta. Average value of sine 2 theta was what? Is it 0? Very good, JNVPTA. So this is going to be 0. So this is your answer. You can take 2 outside and it will become ultimately 1 by root 2 root of I1 square plus I2 square. Or otherwise, this is also correct. I hope this is clear to everyone. Now you will have some confidence about solving RMS current. Now, if we see one more variation in it, there is a kind of graph you can see in the exam. But today's time is over, so we are not going to discuss it here. You can take it as your homework, or some bright student may answer it before ending the session. Should I expect one answer at least? Should I expect one answer at least, or should I end the session? 10 root 2, someone is saying 10 root 2, JNVPTA. Okay. Bacha, question is not asking RMS value, they are asking average value only. They are asking for average value, not asking for the RMS value. Okay. So we will start from here only. JNV LK is saying 10. Okay. So for correct answer, you need to join tomorrow. We will see what's the correct answer. Till then, bye everyone. Thank you everyone. R Kumar, thank you. Bhaskar, Bhargav, everyone, thank you. Roshna,